As promised the other day, today we're going to take a look at actually graphing these functions. We're not going to use a calculator. You'll be expected to do this without a calculator. So here are some steps that I'd like you to follow, and we'll go through throughout the day. One thing we want to do is we want to make sure we find all the intercepts. Second thing we want to do is determine our vertical asymptotes, which we talked about the other day. You set your denominator equal to 0. Third thing, find your horizontal asymptotes, which we know describe our end behavior. We've got those 3 rules that we used the other day. We'll talk about the slant asymptote maybe today if we get into it. If not, we'll do it on Tuesday. And then we're going to sketch the graph using what you know, and you'll see today sometimes we may have to actually pick some points to complete our graph. So I'm going to go through that process every single time we do these. So let's jump into our first example. So in this case, again, I'm going to find my x-intercept. X-intercept, basically we set our numerator equal to 0, but if I do that, you're going to notice that, well, let's do this. Set y equal to 0, but when I multiply x plus 5, I get 3 equals 0, which isn't a true statement. Therefore, there's no x-intercept. Find my y-intercept, set x equal to 0, and I get 3/5. Vertical asymptote, set the denominator equal to 0, and I get x equals -5. And to find my horizontal asymptote, I take a look at the degree of the numerator and the degree of the denominator. This is really x to the 0. This is x to the first. Since the degree of the numerator is less than the degree of the denominator, y equals 0 is my horizontal asymptote. So now I'm going to go through and try to sketch some of this. And again, these are sketches. They're not exact. So I'm first going to graph my vertical asymptote. I go over to -5. And I draw an asymptote here. I'm going to go to y equals 0 and do my horizontal asymptote here. I know I have a y-intercept of 3/5, which is, if this is 1, 3/5 is somewhere around here. Now, from this, I should be able to graph some of my function at this point. I know it goes through this point. I know it has to approach this line, but I know it doesn't cross the x-axis because I have no x-intercepts. So this must do something of this nature and approach that line. I know also it doesn't cross this axis, but it's going to have an end behavior of 0 since that's my horizontal asymptote, and it's going to approach that line here. All right. Now over on this side, I don't know much. So what I'm going to have to do is I'm going to have to pick a point on this side. What point? It doesn't really matter. Just something over here. I'm going to take a look at the function's value at -6. And all I really want to know is I want to know if it's going to be above this line or below this line, because I know it's not going to cross the horizontal axis. So when I plug this in, notice I have a positive on top. We're going to do kind of like a test situation like we did with our inequality problems. And on the bottom, I'm going to get a negative, which equals a negative value. So I know the graph has got to be down here. Therefore, it's got to look something like this. And I'm done with that graph. And you can check that on your calculator if you like, but that's pretty much what you're going to get. Let's take a look at the next example. In this case, once again, I set my numerator equal to 0 to find my x-intercept. So x equals 0. Set my x is equal to 0 to find my y-intercept. So y equals 0. Vertical asymptote, set the denominator equal to 0. And I get x equals 2. Find my horizontal asymptote, I take a look at my highest degree, 1 in each case. Since my degrees match, I divide the leading coefficients. So y equals 1/2 is my horizontal. Now I'm going to take and sketch out what I know. So again, x and y intercept, 0. Vertical asymptote, 2. Horizontal asymptote, 1/2. Somewhere around here. Now once again, I know a little bit about this. In fact, I know a lot more than a little. I know it's got to go through this point here and approach this line. And then I know it's got to go through this point here and approach this line. So there's that part of the graph. Now, I know that if it's going to approach these two lines once again as my end behavior here and my asymptote here, and it's not going to cross this axis, and I know that because I've calculated all x-intercepts to be 0, then the graph has to exist up here, so I just draw it like that. And again, check it on your calculator if you don't believe me, but that's how it's going to look. So in this problem, once again, we will take and find our x-intercepts by setting that numerator equal to 0 and get x equals -7. Y-intercept, set x equal to 0 and get 7/5 of the negative type. Vertical asymptotes, set the denominator equal to 0, factor, and I get -5 and 1, so we're going to have two vertical asymptotes. Horizontal asymptote, take a look at the degrees. Numerator less than the denominator, so the horizontal is going to have y equals 0. Let's take a look at a sketch. There's my set of axes. I'm going to have a x-intercept at -7. Put a dot there. Y-intercept -7/5, somewhere around here. Vertical asymptotes at 1. And -5. Horizontal asymptote at 0. Now this is the first case where we've seen that our graph actually goes through a horizontal asymptote, which is totally okay because all the horizontal asymptote does is describe what the graph does when x gets very big and very small. It doesn't talk about what the graph does when x is in the middle of the graph. Alright, so once again, this horizontal asymptote describes end behavior. So, next thing, I'm going to take and look at this graph and say, well, I have a y-intercept here at -7/5, and it can't cross this line anywhere except the -7. So I know the graph has to move down this way in some way, shape, and form. I don't care how high it is, it's just a sketch. Alright? Now, I don't know anything about this region here, this region to the right of this intercept, or this region to the left of this intercept. So I'm going to have to pick some points. Pick a point to the right of this vertical asymptote, or 1. So I'm going to pick f of 2. Pick a point to the right of that vertical, or of that intercept. So that would be like f of -6. And then pick a point to the left, which is f of -8. Alright? And I'm going to plug it in to the factored form of this equation. And the factored form of this equation is x plus 7 over x plus 5, x minus 1. And the reason why I plug it into the factored form is I just want positive and negative values. So you'll notice when I plug -8 into this function over here, I get a negative on top. On the bottom I get 2 negatives. 3 negatives make a negative. So I know that on this side I'm in the lower quadrant, but I'm also approaching this line. When I plug in -6, you'll notice the top is a positive. I get a negative and a negative on the bottom. 2 negatives and a positive is a positive. So in this side, I have a positive value. Now when I go over to 2 and plug that into this function, I get a positive on top, positive, positive. So everything's a positive, and it's not going to cross that horizontal asymptote because in this case, the only x-intercept is at -7. So that's going to kind of be what the graph looks like. Again, let's go ahead and go through all the basics. X-intercept, 3x squared should equal 0. So x equals 0. Y-intercept set x equal to 0, and I get y equal to 0. Vertical asymptotes, set the denominator equal to 0. Factor, so I get plus and minus 3 in this case. For my vertical, my horizontal, you'll notice the degrees match. Divide the leading coefficients, so I have a 3 on top and 1 on bottom, so y equals 3. Let's go through, sketch this guy out again. So in this case, I have an intercept at 0, at 3, vertical asymptote. At negative 3, I have another vertical asymptote. I have a horizontal asymptote at 3, like so. And let's see what I know about this. Well, I know quite a bit actually. I know that it's never going to cross the axis over in this region or this region because the only calculated intercept is at 0. So if it's not going to cross the axis and approach these two asymptotes, that portion of the graph has to be up here. Likewise, on the very left side, it's never going to cross this axis because the only intercept calculated is at 0. So since it doesn't cross this axis and it has to approach both asymptotes, the graph has to be up here. Now in this case, I really don't know what's going to happen on either side of this. I have an idea, but I don't know. So I'm going to have to pick some points. Once again, I'm going to pick f of negative 1 and f of 1 because it's on either side of this point right here, and I don't know if it's going to go down or up. And once again, I'm going to plug into the factored form of that equation. Factored form of this equation is 3x squared over x plus 3 and x minus 3. When I plug in a negative 1 to this function, all right, you'll notice that on top, I get a positive. On the bottom, I get a positive and a negative, which is a negative. So I get a negative value on that side. When I plug in a positive 1, I get a positive over a positive and a negative once again. And you'll notice it gives me a negative as well. So the graph's going to look something like this. Let's do another one. Here's a case where x-intercept is equal to 0, y-intercept equals 0, vertical, set x squared plus 1 equal to 0. Now we got a problem because x squared is equal to negative 1 is never going to happen. So there are no vertical asymptotes. Horizontal, I will have one of these because degree of the numerator is less than the degree of the denominator, so I get y equals 0. Let's take and sketch this, see what it looks like. No vertical asymptotes, horizontal asymptote at y equals 0, so that's this axis here. And I know I have an x-intercept like so. But I don't know what's happening on either side, so once again I'm going to have to look to either side and plug in a point, f of 1 and f of negative 1. So when I do that, again I'll plug into this function here of 5x over x squared plus 1. When I plug in a negative, the top gets me a negative, the bottom gets me a positive, which gives me a negative value, but as x goes to negative infinity, I have to approach this horizontal asymptote. So this is going to go in the negative direction, but it's going to come back and hug that line right there. When I plug in a positive 1, I get a positive on top over a positive on bottom. So this is going to be in the positive direction, but as I get bigger and bigger, my behavior says I got to approach that line. So it looks something like this. Kind of unique graph. In our last example, we got a little bit to do in this, so I'm going to factor away here. In doing so, I pull out a 3. I get x squared minus x minus 12 over x plus 2 x minus 1. I go through and continue. I have 3 x minus 4 x plus 3 over x plus 2 and x minus 1. So in this case, my x-intercepts, by setting my numerator equal to 0, I get 4, negative 3. My y-intercept is just going to be 18. My vertical, I set the denominator equal to 0. I get negative 2 and 1. And my horizontal, we'll notice once again our degrees match, so divide the leading coefficients and I get y equals 3. Let's go ahead and sketch this guy out. X-intercepts of 4 and negative 3. Vertical asymptotes of negative 2, positive 1. Y-intercept of 18, so it's way the heck up here somewhere. Horizontal of 3. I've got some good ideas as to what this graph looks like. Once again, I know that it goes through this point and has to approach this line as I get further and further out, so I know this is going to have to look something like this, and this will go down here. Likewise on the left side, it's got to approach this line, and then as it gets further and further to the negative direction, it approaches this line. So it's got to look something like that. I know this graph is not going to cross this axis because the only calculated x-intercepts are these two. So I know that this guy is probably got to hook up here and hook up here. And then I'm done. So we covered all the situations where we have equal degrees and degree less on top than on bottom. We haven't done the slant asymptotes. We'll hit that on Tuesday. All right, and then we'll do any cleanup of this kind of stuff as well. So we'll see you then. Take care.